QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's consider this quadratic function. And the first question goes like, what is the vertex of the graph of the given function? If this function is to be graphed, the vertex can be found at -2, 0. In connection to the graph, second question, what is the axis or the line of symmetry of the given function? The line of symmetry is at x equals -2. And for the last question, how many x-intercepts are there in the graph and what are they? For this question, the answer is only 1, and it's -2, 0. Did you get 3/3? If not, please continue viewing this video. For this function, f of x is equal to x squared plus 4x plus 4. Let us try to discuss here how do we solve the vertex, its relationship to the axis or line of symmetry, and the idea of solving or identifying the x-intercepts. Here, we will start with the vertex using the correct coefficients of this given function. The correct coefficients of this given function follows the same coefficients that we have for any quadratic equation. We have the coefficient a, we have the coefficient b, and the coefficient c. Coefficient a is the coefficient of x squared, which is 1, because that's 1x squared. Coefficient b is the coefficient of x, which is 4, and our constant c is 4. Our vertex is a point in a graph where the graph changes its direction. By the way, the graph of any quadratic function is a parabolic graph. There is a point there where it changes its direction to either from increasing to decreasing or decreasing to increasing. And that's the vertex. It's also called as the point of inflection. Since it's a point on the Cartesian plane, it is a combination of both x and y axes, y coordinates rather. So for the x coordinate, we have -b over 2a. Simply plug in here the coefficients to get your correct x coordinate. As for your y coordinate, you have 4ac rather, minus b squared over 4a. Same thing, substitute all the values here to get your y coordinate. But of course, this can be left out already. Simply get the value of x coordinate here, and just like any other point on our Cartesian plane, when this value of x will be substituted in our function, that is automatically the value of y coordinate. So let's start. X here is again computed as -b over 2a. Hence, you have here negative of b, which is 4, over 2 times 1. We'll have here the result of -4/2. In short, x is equal to -2. This is the value of the x coordinate of our vertex. Then we are to use that and substitute such value here. So we will be changing all the x variables for this given function into -2. Because f of x is also known as the y in the sense of Cartesian plane. So we have f of -2 here. Please do not forget to use parentheses so that you are going to include the negative sign as you take the square here, and you will also consider its sign when you multiply it by 4 before you add to 4. So you have the square of 2 rather is 4. You will have here minus 8, and you will have here plus 4. In short, the value of f of negative 2 is 0. Together with the value of x, our vertex now is a point at negative 2 and 0. Okay? So this is the vertex of this given function. Here we were not asked about the graph, but let me just illustrate this in a graph so that we could draw some analysis and predictions on the next few items. The vertex is at negative 2 and 0, so it's here. Okay, our graph is mentioned to be a parabolic graph. So we actually need exactly 5 points, or at least 5 points to do that. But since our task here is not graphing, let's just have it like this. Considering our a coefficient being 1, we know that the concavity for the parabolic graph, when a is positive, it opens upward. So it's like this. Okay? Okay, that is, if my graph is accurate, that's the graph of our parabolic graph. So this is, of course, x. This is y, or also known as f of x. So y is equal to f of x. This is our graph here. So the next thing that we are trying to discuss here is this axis here. This is an imaginary line passing through the vertex, which is also known as the axis or line of symmetry. From the name itself, symmetry, it divides the parabolic graph. If my graph is accurate, it divides this parabolic graph into 2 mirror images. Okay, so if we're going to look at this one here, this is a mirror image of the other, and vice versa. So we're talking about this. What do we name this one here? This is a line. This is an imaginary line. That's why it's axis or line of symmetry. In our grade 8 math, we know that in our Cartesian plane, if our line is a vertical line, its equation is x equals to something. That something is the point on our x-axis where that vertical line intersects. So this is the point here which corresponds to our vertex. And here's now the hint or the connection between the vertex and the axis or line of symmetry. Even without this graph, we can determine the axis or line of symmetry just simply picking out the x-coordinate of our vertex, because it is the value, or it's a point where this vertical line intersects the x-axis, and the value of x for this point here, which is actually our vertex, is at negative 2. That is why the axis or line of symmetry is x equals negative 2, similar to the x-coordinate of our vertex. So even without this graph, you can automatically solve for the axis or line of symmetry just by picking out the x-coordinate of your vertex. Okay, that's your axis or line of symmetry. Now for our third and the last concern for this video, we're talking about the x-intercepts. Okay, the x-intercepts are a point on our x-axis where the graph intersects. Look at our graph. This is our graph here. From left to right, it goes down. Once it reaches this point, which is our vertex, it moves up. There's only one intersection with the x-axis, and that's our vertex actually. So we only have one x-intercept here. Okay, and that x-intercept, as mentioned, is our vertex. So it's at negative 2 and 0. Okay, however, this is because we have the graph, right? But what if we don't have the graph? Because just like in this video, we were not asked about to draw a graph. How do we know that x-intercept? The x-intercept actually is equal to or the same as the roots. The number of x-intercepts here is equal to the number of unique roots for this quadratic function. So if we're going to have the equivalent equation of our function, x squared, then we have here plus 4x plus 4 equal to 0. We can now factor this using AC way, or you could even use here your quadratic formula, but I'm just going to show here factoring so that we could also practice this. A times c, we have here a and c, so 1 times 4, you will have here 4. the possible factors of 4 is 1 and 4, negative 1, negative 4, 2, 2, negative 2, and negative 2. Only one pair of factors when added will result to our b coefficient of 4. These are our roots: x plus 2 and x plus 2. And by the way, we could see here that this is actually a perfect square trinomial because our factors are just the same, equal to 0. With this is only true when one or both of them are equal to 0. Them in a sense that the factors, so they can be equal to 0. So we have here x is equal to negative 2. Here as well, x is equal to negative 2. We see that we have the same value. That is why we only have one x-intercept. Since we have here negative 2, multiplicity of 2, there are 2 of them. And at the same time, even without the graph, just by looking at the roots, we can determine the exact x-intercept, not just by the count. We know that there is one x-intercept, but we know here what is also our unique x-intercept. An x-intercept is also a point on our Cartesian plane, hence it's a combination of our x and y coordinates. X-intercepts are points on the x-axis, hence y is 0, and simply pick this value, negative 2. So you only have one x-intercept, and that's actually related to our roots. And further, look at our vertex, because our vertex is the point where our graph and x-intercepts intersect. This is also our x-intercept here. So if we have something like this, they are actually interrelated to one another. Simply use the roots here for x-intercepts so that you could also verify the number even without the graph and even the name or the point itself. These are all the discussions for the vertex, axis or line of symmetry, and the intercepts for this QuadQuiz. Subscribe now!